Hi everyone, welcome back to Lulumath. This video is on completing the square, but this time we're going to be looking at examples with non-integer values. So the background knowledge that you will need to know is you need to know how to complete the square. And if you need a refresher on this, you can find that video at lulumath.com or on the Lulumath YouTube channel. In our first example, we are asked to rewrite the expression below with an equivalent expression that has a perfect square trinomial, and then we're going to factor. So here is our expression, x squared plus 7x plus 11. So since the a value is 1, right here we've got 1x squared, we can go straight to dividing the b value by 2 and then squaring it. Well, our b value is 7, so I'm going to take 7, divide it by 2, and since 7 is not evenly divisible by 2, I'm just going to leave it as 7 over 2, and then I'm going to square it. Now, 7 squared is 49, and 2 squared is 4, so 7 over 2 squared is 49 over 4. Now I want to add that value to the expression, but don't forget to subtract it to preserve the expression. So I will copy down this x squared plus 7x. I'm going to leave a little bit of space, and then I'm going to write down this plus 11. And now I'm going to add 49 over 4. But if I add 49 over 4, remember I have to subtract it because 49 over 4 minus 49 over 4 is 0. And when I add 0 to any expression, I haven't changed it at all. Now I have a perfect square trinomial. Here is my perfect square trinomial. So all I need to do is factor it and simplify these extra values that I have here. So when I factor this, I will end up getting x plus, remember it's the b value divided by 2 over here, 7 over 2 quantity squared. And I know this works because 7 over 2 when I square it, I get 49 over 4. And 7 over 2 when I double it, I get this 7x, which is exactly what would happen if I were to actually expand this all out. Now here I have minus 49 over 4 plus 11. So I'm going to make this 11 over 1 and I'm going to get a common denominator. My common denominator is 1, so I'll multiply numerator and denominator over here, both of them by 4. So I will copy down this minus 49 over 4 that we have here. And 11 times 4 is 44 and 1 times 4 is 4. So I haven't changed this 11, I just rewrote it as 44 over 4. And when I put these two together, I end up getting negative 5 over 4. Just copy down this x plus 7 over 2 quantity squared, and this is my equivalent expression to this x squared plus 7x plus 11. Now I want to verify that x squared plus 7x plus 11 is really the same thing as this quantity x plus 7 over 2 squared minus 5 over 4. So if you see in my first line here, I've got x squared plus 7x plus 11. I will turn that graph on. In my second line, I have this x plus 7 over 2 squared minus 5 over 4. I will turn that graph on, and they are exactly on top of each other, which means that x squared plus 7x plus 11 is equivalent to the quantity x plus 7 over 2 squared minus 5 over 4. All right, our next example asks us to rewrite the expression below with an equivalent expression that has a perfect square trinomial, and then we're going to factor. So this time I have a leading coefficient of 2. I've got 2x squared plus 9x minus 10. So the first thing I need to do is factor out the leading coefficient from ax squared plus bx to make the a value 1. But remember, I'm not going to factor it out of this c value. So let's go ahead and see what that's going to look like. So if I take a 2 out, because that's the a value, I now have an x squared, which is what I need in order to complete the square more easily. And then 9 is not evenly divisible by 2, so I'm going to leave it as 9 over 2x. And then I'll leave this minus 10 at the end. Now I want to take my new b value, which is this 9 over 2 here, and I'm going to divide it by 2 and then square it. So I'm going to write 9 over 2 divided by 2 again, and then I'm going to square it. But remember, when we divide fractions, it's the same thing as multiplying by the reciprocal. Well, this is technically 2 over 1. So the reciprocal of 2 over 1 is 1 over 2. But I still have to square it. So now when I multiply across, 9 times 1 is 9. 2 times 2 is 4, and then I'm going to square it still. And 9 squared is 81, and 4 squared is 16. Now I need to add that value to the expression, the one we have here, but don't forget to subtract it to preserve the expression. So I just copied down what we have here, And then I'm going to add this 81 over 16. So I'm going to write plus 81 over 16. But if I add 81 over 16, I also have to subtract 81 over 16. And technically, this is 2 times this 81 over 16 and 2 times this negative 81 over 16, which is why we can't forget to distribute the leading coefficient. So here I have 2 times x squared plus 9 over 2x plus this 81 over 16. But I'm going to distribute this 2 through to this negative 81 over 16, and I will do this multiplication on the side. So it's 2 times negative 81 over 16, but I will make this 2 over 1. And 2 and 16 are both divisible by 2, so when I divide 2 by 2, I get 1, and when I divide 16 by 2, I get 8. So when I multiply across, 1 times negative 81 is negative 81, and 1 times 8 is 8. So I can say here that I have minus 81 over 8, but I still have this minus 10 to copy down. Now what I have inside of here is my perfect square trinomial. So I'm going to rewrite this full expression that I have down here so that I can factor it and simplify the extra values. So I will copy down this 2, and when I factor this, I want to know what times itself gives me 81 over 16, but when I double it gives me 9 over 2, and I can find that value from this work that I did over here before I squared it, because I took my 9 over 2, divided it by 2, and then squared it to get this 81 over 16. So this 9 over 4 is the value I'm looking for. So I can say x plus 9 over 4 quantity squared. And then over here, I've got minus 81 over 8 minus 10. This is technically 10 over 1. So I'll do my work on the side. I'm going to multiply this 1 by 8, as well as the 10 by 8, because that's my common denominator. So I get negative 81 over 8 minus 80 over 8. Which altogether will give me negative 161 over 8. So I'll put that at the end here, and this is my final answer. At this point, I would like to know, is this expression truly equivalent to the original one we had here? So if you see in our first line that we have here, we've written this 2x squared plus 9x minus 10, but as a parabola with y equals, and we have this red parabola. And then if you look in the second line, it matches this expression that we have here, but again written as an equation, y equals, and the blue parabola is right on top of the red parabola, meaning that our two expressions are for sure equivalent to each other. In this example, we could have changed this 9 over 2, this 9 over 4, and this 81 over 16 into decimals instead of fractions if we wanted to. And the reason why is because these will end up being terminating decimals. However, sometimes we'll end up with repeating decimals, and there's no way to write it all out without having to get to a point where we will be doing some rounding. So that makes our answers not exact answers. So I strongly suggest you keep them as fractions, but still understand what these values are as approximations, so that way we can visualize what these numbers mean when we get to a point where we are solving equations or graphing parabolas. So in our final expression that we have here, we've got negative 3x squared plus 8x plus 6, and we still want to factor out the leading coefficient. But because our leading coefficient is a negative 3, we can't change these into decimals in this example because many numbers divided by 3 will end up being repeating decimals. I have negative 3x squared plus 8x, and I'm going to leave a little bit of space, and I'm going to write plus 6 at the end. When I factor out my leading coefficient of negative 3, I end up getting x squared, and then 8 divided by negative 3 doesn't divide evenly, so I will leave it as negative 8 over 3x. I'm going to leave a little bit of space, and then I'm going to copy down this plus 6. Now I want to divide the new b value by 2 and square it. So here's my new b value that I'm going to deal with, because now my a value is 1, which will help me to complete the square more easily. So I'm going to take negative 8 over 3 and divide that by 2 and then square that. Well, remember, when we divide by 2, it's the same thing as multiplying by the reciprocal. So we're going to multiply by 1/2, and we're still going to square it. Now, if you look and see, 2 and negative 8 are both evenly divisible by 2. So this 2 becomes a 1, and this -8 becomes a 4. So when I multiply across, -4 times 1 is -4, and 3 times 1 is 3. And then I still have to square this. Now the nice thing is right here is this is a little bit easier to deal with. So don't forget to put the brackets around this -4/3, because when you square a negative number, it becomes a positive number. And the brackets indicate that we are squaring that negative. So -4 times -4 is +16, and 3 times 3 is 9. So this is the number that I'm missing in order to be able to complete the square. So now I want to add that value to the expression, but I don't want to forget to subtract it to preserve the expression. So I will copy this part down here. So I will add the 16/9 we got, but if I add it, I also have to subtract it, so -16/9 right here. Now, I'm going to copy down this -3 again. I've got x squared minus 8/3x plus 16/9, but that is the end of my perfect square trinomial, so I'm just going to close my brackets here, and then I will distribute this -3 through to this -16/9. Let's do this on the side. So I have -3/1 multiplied by -16/9, and 9 and -3 are both divisible by 3. So when I divide 9 by 3, I get 3. When I divide -3 by 3, I get -1. And when I multiply across, -1 times -16 is +16, and 1 times 3 is 3. So that means that I have a +16/3 on the outside of my brackets, and then I still have this +6. So we now have a perfect square trinomial. It is this expression right here, so we will factor it and simplify the extra values. So I will copy down what I have here, and I will bring down this -3. And when I factor this perfect square trinomial here, it will be x minus 4/3 quantity squared, because again, if I were to factor this out right here as a perfect square trinomial, I would use -4/3, because -4/3 times -4/3 is 16/9, and when I double -4/3, I get -8/3. Now I want to put together this 16/3 plus 6. So let's do this on the side. So 16/3 plus, this is technically 6/1, and I want my common denominator to be a 3. So I'm going to multiply the numerator and the denominator of my second term by 3. So this ends up becoming 18/3, and I still have 16/3. And when I add 16/3 and 18/3, I end up getting 34/3. And this is my final answer after I have completed the square. Now, we can verify this using Desmos. I suggest that you do this on your own, compare it with the original graph, and see if it will look exactly the same as the second graph, and it should, so that will verify for us that we have equivalent expressions. Thank you for watching. If you have any questions, let me know in the comments below or at lulumath.com, where you can find blank or completed notes for this video. If you found this to be useful, please share with others and subscribe. Thank you. We'll catch you next time. Bye.